What you're seeing right now is the hybridization of the carbonyls. The moment we say this word carbonyl, such a important functional group it is, you can see they are present in aldehyde, present in ketone, present in esters, carboxylic acids, and carboxylic acids and their derivatives. Could be acid chlorides, could be amides, could be acid anhydrides, etc. Right? So very important functionality is this carbonyl. So we're looking at this carbonyl where I could see it is forming 3 sigma bonds here. So if it is forming 3 sigma bonds, the hybridization is sp2 hybridization. Similarly, in oxygen, you could see it is having 2 lone pairs. It's having 2 lone pairs and 1 sigma bond it makes. So that is also in sp2 hybridization. So both carbon and oxygen are exhibiting sp2 hybridization here. sp2 means it is trigonal planar. What is the bond angle for trigonal planar?
120.
120. That's right. It's 120 degrees. Now, the very important thing that happens with respect to this carbonyl, as we mentioned already, this carbon is having electron deficiency. Means what? It doesn't mean it is not an octet complete. It is octet complete only because oxygen is electron withdrawing group. It keeps pulling the electron cloud towards it. And that is the reason why the carbon feels electron deficient. You can see it is having delta plus and oxygen is having delta minus. In other words, we can understand that if there is a nucleophile that has to attack this carbon, then it is easy for this nucleophile to attack this carbon because of its electropositive nature. Also, there is a large dipole difference is also there because oxygen is electronegative, carbon is feeling electropositive. As a large polarity is also available here. The molecule is also becoming polar in nature. We are starting with the preparations of aldehydes and ketones. Number one, we start preparing it from the primary alcohol. What do I mean by primary alcohol? Arsenic, methanol. Is this primary alcohol? Arsenic, is this primary alcohol?
Yes, ma'am.
Tanuja, is this primary alcohol?
Yes, ma'am.
Surya?
Yes, ma'am.
Ishan?
Yes, ma'am.
What is this? Everyone says it's a primary alcohol. Then what about this alcohol? Is this a primary alcohol?
Yes, ma'am.
Yes, ma'am.
Array. Surya, tell me, why do you say it is a primary alcohol?
Ma'am, because it's attached to 1 degree carbon.
Which one? OH group.
Yes, ma'am. OH group is
Okay,
attached
what
to 1
about
degree.
here? Can you say this carbon is 1 degree carbon?
Yeah, 0 degree alcohol.
So this is not a primary alcohol, it's just a methyl alcohol, that's it. Only ethanol is a primary alcohol. You understand the difference? Okay,
Yes,
so
ma'am.
we are using a primary alcohol here with strong oxidizing agents here. Oxidation is nothing but addition of oxygen or removal of hydrogen here. So I start with RCH2OH. I provide a very strong oxidizing agent. You can understand the H2 is removed and oxygen is getting attached here. Can you see this? And it is becoming RCOOH. It is getting converted into carboxylic acid. Which alcohol? Primary alcohol. Because it is having 2 hydrogens, it is going for further oxidation. Will this oxidation happen in one single step? No. It first gets converted into aldehyde or CHO. Again, it gets converted into carboxylic acid. I repeat, in the first step, you
Ma'am,
can see.
can we isolate this aldehyde?
Yeah, you can isolate it. But with very strong oxidizing agents, it's very difficult. It will be very fast.
Yes, ma'am.
In the first step, you can see one hydrogen is removed. In the second step, you can see one oxygen is being added. Can you see this? One more oxygen is getting added. So I take a primary alcohol. I treat it with very strong oxidizing agent. As Ishan is asking, will I be able to isolate this aldehyde? It's very difficult because the reaction will be very fast here, quick. Okay, so what are the set of very strong oxidizing agents we have? Generally, the very common strongest oxidizing agents, permanganate in both acidic medium and in alkali medium, dichromate in acidic medium, chromic acid, H2CrO4 is chromic acid, sodium hypochlorite, NaClO. This is AC means acetyl group, CH3CO group is there, and one OH is here. So it is acetic acid.
Ma'am, CrO3 is Collins reagent, right, ma'am?
Wait. The last reagent you are seeing is Jones reagent, chromium trioxide in acidic medium. Depending upon the medium, the reagent is different. If it is basic medium, then you call it as Collins reagent.
Oh,
If
okay.
it is acidic medium, we call it as Jones reagent.
Ma'am,
So,
wouldn't it be NaOCl like instead of NaClO?
both are same. No, not much difference. People write it in either ways.
Okay.
So primary alcohol we take, it gets converted into acid. There is no stopping here. Complete oxidation. We call this as complete oxidation. What if I take a secondary alcohol? What is secondary alcohol? Where the alcohol is attached to the carbon that is attached to two more carbons. That is called secondary alcohol. Here you can see this carbon is having only one hydrogen, isn't it? In primary alcohol, two hydrogens were there, so it went to aldehyde, then further it went to oxidation to form acid. But here there is only one hydrogen here. So I cannot expect acid to get formed. Instead, what happens? It stops with ketone itself. Primary alcohol gives acid, secondary alcohol gives ketone. Very important one. Got it?
Yes, ma'am.
Yeah. So, ma'am, if I oxidize primary alcohol, I get acid. If I oxidize secondary alcohol, I get ketone. What if I oxidize a tertiary alcohol? There will be no reaction at all. Why? Because this carbon does not have any hydrogen at all. Oxidation means I will remove hydrogen. No? This has already satisfied its valency with 4 bonds. There is no hydrogen. So there can be no reaction here. You understand? Tertiary alcohol cannot be oxidized, even though you use very strong oxidizing agents. But if further I provide this oxidizing agent, they will undergo combustion. They'll start burning into carbon dioxide. That is the only thing that you can do. You can't oxidize them to any other functionalities. Clear till this?
Ma'am, I left for a second, ma'am. What happened?
I was talking that tertiary alcohols cannot be oxidized
Ah,
because they do not have hydrogens, so they can't get oxidized. But further, I am providing oxidizing agent. They will undergo combustion reactions to provide CO2.
hmm. Yes.
Yes. Asini, tell me what will be your product? Asli, are you there?
Yes.
Yeah, tell me. What will be your point? There are two OH here. Tell me how are they going to get oxidized and what will be your point?
The alcohol,
What about this alcohol? This part? What will
it
it
does
be?
not get
Ah,
oxidized.
okay.
It
Why?
remains the same because
Why?
it's a tertiary alcohol.
Very good. Wonderful. What about the next one?
The next one is a secondary alcohol, so it gets oxidized to a ketone.
Very good. That's right. Yes, I answered it correctly. This alcohol is a tertiary alcohol, so it does not get oxidized. But this alcohol is a secondary alcohol. It gets oxidized to form ketone here, right? So what we have discussed is the oxidation of the primary alcohol, and the secondary alcohol to provide aldehydes to acids and then secondary alcohols to ketones. But I don't want this. I want to selectively oxidize them. I want to control my oxidation. In that case, what will I do? I use selective oxidizing agents here. These are the set of selective oxidizing agents PCC, pyridinium chlorochromate, PDC, pyridinium dichromate, Swern oxidation, DMSO, dimethyl sulfoxide, carbonyl chloride, ET3N is triethylamine. It's a base. DMP, decimartin periodinane. These are the structures of the common mild oxidizing agents here. You need not remember the structures. Generally, they provide you the names only often. Even though it's available in the G drive, you can look at it. Pyridinium chlorochromate. Pyridinium means it is a salt. That means nitrogen is carrying a positive symbol like ammonium. Ammonium is NH4 plus, right? Similarly, pyridinium, positive charge. Pyridinium dichromate. You can see this is one chlorochromate. Here it is dichromate, Cr2O72 minus. You can see this. Dichromate it is. Swern oxidation. We said R3N or ET3N, anything. Some base I have. Dimethyl sulfoxide, DMSO. This is the structure of DMSO. Dimethyl sulfoxide, and this is COCl twice. Carbonyl chloride. Okay. Now this is decimartin periodinane. You can see this iodine is present here, so we call it decimartin periodinane. All these things are mild oxidizing agents only. What do I mean by that? I start with primary alcohol. They oxidize them to aldehyde only. No further oxidation is allowed. But in the case of secondary alcohol, in my previous case itself, I didn't form acids. It was only ketone. So the products are same with respect to strong oxidizing agent as well as with mild oxidizing agent with secondary alcohol. Is that clear for you all till this?
Yes.
As Surya was asking about the Collins reagent. So Collins, what's the difference between your Jones and Collins? Jones was having chromium trioxide in acidic medium. Here chromium trioxide in a basic medium, pyridine. Here it is a very choiceful reagent for primary alcohol alone. Secondary alcohols also will react, but not that much. It is not that much compatible here. So I take primary alcohol. This is also a selective oxidizing agent. Remember, Jones was strong oxidizing agent, but this is selective oxidizing agent. When it gives primary alcohol, should give aldehyde, right? Yes, it gives aldehyde in a good yield. Ketones can't be prepared because I'm not using for secondary alcohol. I use it only for the primary alcohol. So ketones can't be prepared here. Cleared up till this?
Yes, ma'am.
Right. The next reagent is NBS. N-bromosuccinamide. N-bromosuccinamide. We have already learnt about the usage of the NBS. Surya, what is the use of NBS?
Allylic bromination.
That's right. NBS undergoes an allylic bromination. Also, NBS is a mild oxidizing agent. Okay. So here I go with N. This is N. To this N, the bromine is attached, and this amide is formed from succinic acid. So I call it as N-bromosuccinamide. With this, I am using a primary alcohol. So if it is a selective oxidizing agent, what will primary alcohol get oxidized to? An aldehyde? Yes, I get an aldehyde here. Understood? So please note down, NBS is also a mild oxidizing agent for primary alcohols to give you aldehyde.
Ma'am, this is only for primary alcohol, right, ma'am?
Huh? No, even
Ma'am,
for
this is also
secondary.
only.
No, secondary also.
Okay. Okay, ma'am.
Yes. The next reaction, very popular reaction. We will have the glimpse of this reaction even in D and F block elements once we start the chapter. For the catalyst purpose, the process is called Wacker's process. Process is called as Wacker's process, where you convert an alkene into carbonyl compound. Alkene into carbonyl compound, and the common set of reagents are oxygen, water, palladium chloride, and copper chloride. The main catalyst is palladium chloride. The co-catalyst. Co means additional, supporting catalyst. Co-catalyst is copper chloride. Okay, so ma'am, how do I understand this reaction here? We are not going to the typical mechanism of it, which is not involved for JEE Advanced as well. So what you need to remember is that consider this is a symmetrical alkene. So one part takes hydrogen, another part takes oxygen. That's it. You can see it is becoming CH3, CH4. And repeat, one, just like your oxymercuration, demercurations and all, no? So I am just converting it to an aldehyde. But when it is among an unsymmetrical alkene, you can see the carbon that is more substituted takes the electronegative part, oxygen here. Can you see this? RCOCH3. So please make a note of Wacker's process. Unsymmetrical alkene, add the oxygen, make it as a carbonyl. The more substituted carbon.
More substituted carbon means attached to more alkyl groups.
More alkyl group, correct.
Yes.
In other words, it is having less number of hydrogen. Okay. Right. I am skipping this part and all. It is not for year level. It is for gate level. I am going for the next reaction. Ozonolysis. I have done ozonolysis several number of times. So just if I have alkene, I will be able to do carbonyls here. The presence of ozone and zinc. DMF, dimethylformamide, or acetic acid is provided. We call this as reductive ozonolysis. In case hydrogen peroxide or water is provided, we call it as oxidative ozonolysis. Now, how do I differentiate the products here? Break the double bond, add oxygen on either side. In oxidative ozonolysis, if these reagents are provided, the sp2 hybridized carbon, if it is having hydrogen, then add oxygen in between that also. I repeat, in reductive ozonolysis, your step stops here. I just had 2 oxygens over. Remember, even though if you are having an sp2 hybridized carbon that is having hydrogen, no addition of oxygen is happening. Only in oxidative workup, I introduce one more oxygen in between. Now look at the products here, R, CO, R. I created a ketone. Look at this part. This is R, C, O, and here is OH. I am forming acid here. So in oxidative ozonolysis, you will be able to form acids. Understood?
Yes, ma'am.
Right. And I guess you know how to, from the products, how to meet the reactant, isn't it? 1 minute. Hello? Yes? Yes, sir?
Good morning, ma'am. Calling from NCERT-based.
Which academy, sir?
Yes, sir.
Okay, sir. Tell me, sir. Tell me. Sir, I am unable. I'm
So
not.
your resume has been
Okay.
shortlisted, ma'am.
Okay,
You
sir.
will be having 3 rounds of interview. First round will be a written test, second is demo, and third round is HR round.
Okay, so where is the placement, sir?
Maharashtra, ma'am.
Maharashtra. Okay, sir. Okay.
Where you are located, ma'am?
I am in Seliyur, sir. Tambaram.
Okay, fine, ma'am.
Okay, sir.
Can I send the link, ma'am,
Yes, please.
to
Sir.
WhatsApp?
Yes.
Okay, no worries. When you can take the test?
Possibly by today afternoon or by evening.
Okay, and the link will be open till evening 8:30.
Okay.
You can take the test at your convenient time.
Okay. Thank you.
Okay, thank you.
Yes. So when the products are provided, how do you go to the reactants? As you mentioned, remove the oxygen in between them and just club them by double bonds so that you go to the reactants. Right? The next reaction is called Kucherov reaction, where the alkynes are converted into carbonides. Kucherov reaction is having the reagent which is very similar to oxymercuration, demercuration. In oxymercuration, demercuration, you had mercuric salt, right? HgOAC4, NaBH4. You remember? OH minus. This is oxymercuration, demercuration reagent. Kucherov is a special name given to the same type of reaction when alkene is participating. Here also I am having Hg2 plus mercuric salt in the presence of acid and water. So now it is also going to follow Markovnikov principle, where I will be adding OH to the more substituted carbon. So this carbon is more substituted because it is having the R group. So R, C, OH, the triple bond will become double bond, CH2. I can see this can form keto-enol tautomerism here. So upon keto-enol tautomerism, what will it form? It will form a ketone. I hope you all know keto-enol tautomerism. We have learned it already, right?
Yes, ma'am.
I mean, in this case, ma'am, both are substituted. I'm considering this is also this also is same CH3. This is also some CH3. Then what will I here? This could take one time OH. Next time this can take an OH. Both are possible. Okay, da?
Ma'am, if the both the R groups are same, then it is the same product, right, ma'am?
No, not about the same R. I'm taking there is some methyl group or ethyl group is there in that case. Here it is hydrogen, na. There is difference, na.
Okay. Yes, ma'am. Yes, ma'am.
The next reagent is dicyamyl borate. Very similar to your anti-Markovnikov rule. That was followed by diborane. Do you remember? I guess BH3, THF, hydrogen peroxide in the presence of alkali. Hydroboration reaction. Do you remember hydroboration reaction?
Yes, ma'am.
Yeah, where you added OH to the less substituted carbon of the olefin. Same thing. This is again a boron compound only. This is also a boron compound. Plus BH3. Here it is not BH3. Instead, it is dicyamyl borane. Amyl means isopentyl group. Amyl means isopentyl. Dicy means both. Two times amyl is repeating itself. Look at this carbon. 1, 2, 3, 4, 5. 5 carbon. Here also it is 5 carbon. So I called as dicyamyl borane. You can see I am taking an alkyne here. Dicyamyl borane, hydrogen peroxide, sodium hydroxide. Same set. Can you see this? BH3, H2O2, OH minus. Same set. So what reaction should it undergo? Anti-mark. Where will OH attack now? To the less substituted carbon, this side. So that I have the triple bond becomes double bond here. It is enol. Go for the keto-enol tautomerism. It forms an aldehyde here. Is that clear for you all?
Yes, ma'am.
Yes, ma'am.
The next reaction is reduction reaction. We also generalize as hydride reduction. So we are using the reagent dibol H. Diisobutyl. B goes for butyl. Al is aluminium hydride. Dibol H. Ma'am, why it is H? Because this H is going to go out as H minus. Hydride H minus. This is the one which is going to attack this carbonyl here. H minus attack is going to happen here. Okay. That's the reason we call it as dibol H, hydride. Just like lithium aluminium hydride, just like that. So I take an ester, dibol H, in the presence of water at a very lowest temperature. Ester gets converted into aldehyde. Very phenomenal reaction where you convert a ester into aldehyde. Let's go for the mechanism, though the mechanism is not important for us, but still. I have aluminium dibol H here. I am taking an ester here. Okay. So what's happening? Look at this aluminium. This aluminium is having only 6 electrons. It is octet incomplete. So what happens? This oxygen lone pair attacks this aluminium. Now since the oxygen loses the lone pair, it carries a positive charge. This is step 1. In step 2, since aluminium has got now formed 4 bonds, isn't it? Aluminium maximum capacity is formation of 3 bonds only. It formed 4 bonds, so its formal charge is -1 now. But man, oxygen is having positive charge. It is resonance unstabilized. So I have to balance it, right? So this H minus is coming and attacking this carbon so that this bond cleaves to this oxygen. So that oxygen restores its lone pair. Now you can see oxygen lost its positive charge. Can you see this? And what happened to this hydrogen? It got attached to this carbon. Can you see this now? Everyone?
Yes, ma'am.
Asini?
Yes, ma'am.
Nujo, can you understand till this?
Yes, ma'am.
Right. Now the next step. Now I'm naming this as hemiacetal. What is this hemiacetal? Consider I'm having carbon. I'm having OR. Yes. And I'm having H. And I'm having some R. And I'm having some OH here. This is called as hemiacetal. Look at this carbon here. H. OR. This is OR, right? Hydrogen. This is hydrogen. And this whole group is some R. And this one that you're seeing right now is some O aluminium species, which is very similar to OH species. This is hemiacetal. You will be learning it in carbohydrate chemistry as acetals and hemiacetals. Same carbon hydrogen R, OR, and there is no OH, instead there is OR again. Then I call this as acetal. This group will be called as acetal here. Okay, the next group, last one. I treat it with water, H2O I am giving. You know aluminum is a very active metal, isn't it? So what happens? This aluminum, this oxygen bond gets cleaved in here, and this OCH3 gets out as OCH3 minus. So that aluminium grabs this OCH3 minus, so that it goes as AlOCH3. Now what have you formed? You formed an aldehyde. Right? Now the question is, ma'am, why should I learn this mechanism? The question is, if in case they have provided diball D instead of diball H, they will ask you whether it will form D only, because from diball H only the hydrogen is attacking here. Can you see this? So whatever is coming out, that will attack. I will have diball this D instead of H. Is that clear?
Yes, sir.
Correct. Alright. So now, ma'am, is this applicable for both aromatic as well as aliphatic? Absolutely. You can apply this for both aromatic as well as aliphatic esters. So for the conversion of methyl benzobate to benzaldehyde. What is methyl benzobate? I have this. This is benzoic acid. If apart from this hydrogen, something else is replacing it, like sodium, I call it sodium benzobate. Here it is methyl benzobate. So this H is replaced by methyl group. Is this an ester?
Yes, ma'am.
Yeah, it's an ester. So they're asking me to convert this ester into aldehyde. So what should I use? I should use diball H in the presence of water, so that it gets converted into benzaldehyde. Understood?
Yes.
The next use of diball H is for the conversion of nitrile into aldehyde. So the conversion of nitrile into aldehyde in the presence of water. So this carbon is remaining here, the H is attacking here, and you see the oxygen from water is coming in. Nitrile to aldehyde. Okay, Pap?
Ma'am, in this case, if they give dibaldi again, here
Again,
also
I
I
will
should
like
give
RCOD.
C.
Yes, yes, yes.
Okay, yes, ma'am.
The next reaction is from acid chlorides. If I have RCOCl, we call this as acid chloride because it is a it is formed from acid, carboxylic acid. I use thionyl chloride. It's the best reagent here. RCOH in the presence of thionyl chloride gives RCOCl plus SO2 plus HCl. Both are gases. So easy removal of the byproducts. Easy recovery of my main product. So SOCl2 is the best one. We call it as acid chloride. Also, people call this as acyl halides. Why acyl? RCO group is called acyl group. I have RCOCl. If I have RCOCl in the presence of lithium aluminum hydride, if I use, they will provide me alcohols. I repeat, I hope you remember, I had this primary alcohol I had, RCH2OH. I oxidized it to aldehyde, isn't it? If alcohol upon oxidation is giving aldehyde, what will aldehyde on reduction give?
Alcohol.
Alcohol. It's the reverse process it is. Alcohol on oxidation is giving aldehyde. Then aldehyde on reduction should give alcohol. So it will give alcohol, right? So if I take an lithium aluminum hydride, it is a very strong reducing agent. RCOCl will give me alcohol itself. RCH2OH will provide. In case I am not using lithium aluminum hydride. Instead, I am using some bulky participant of lithium aluminum hydride family, LAH, short form. You can see LiAlH is there, then 3 hydrogens are being replaced by tertiary butoxide, bulky na tertiary butoxide. Correct?
Yes, please.
Yes. Bulky group it is, isn't it? So this bulky group is not allowing for further reduction, so that it stops with aldehyde itself. I repeat here, RCOCl should have become RCHO, or CHO only should have become alcohol. Lithium aluminum hydride is very strong reducing agent, so it further reduces it to alcohol, but La is not like that. It's very bulky, so it stops with aldehyde itself.
Ma'am,
Hmm.
if it was LiAlH3 and then tertiary like butoxide 1, then
Hmm.
what would happen?
Then also it will be for retarded reduction only. Bulky
Okay.
group is there.
But in like would there be an aldehyde being a major product and alcohol being minor product in that case? Like, will it still be only aldehyde?
We generally do not have such reagent. La means it's only 3 times of tertiary butoxide.
Oh, okay.
It's a standard reagent.
Hmm. Yes.
So the same reagent can also be used in aromatic molecules. You can do. What is the name of this molecule, Ishan?
Uh, benzoyl chloride.
That's right. Very good. The name of the reactant is benzoyl chloride. You can see it's getting converted into benzaldehyde. The next reaction is with respect to Grignard reagent here. With esters, we are reacting Grignard. We are trying to synthesize ketones. So I take Grignard. Grignard is an organometallic compound which is having R minus and Mg plus X. So this R minus is a nucleophile, attacks the carbon and the double bond O shifts. So that it will become O minus, isn't it? This Mg plus X will go on club with it. So that becomes OMgX and R double dash is there. Followed by water hydrolysis. Mg is a very active metal, definitely wants to go with OH, right? So this bond cleaves in and this R dash goes out. So that I created a ketone. Clear, pa? Along with
Yes.
an alcohol. What if I use 2 moles of Grignard? What will be your final product?
Would be tertiary alcohol. Like
Very good, that's right. Ester with 1 mole of Grignard gives you ketone. If I use 2 moles of Grignard, it will give me tertiary alcohol. Okay? Right. Let's go to the next one. We are trying to convert the nitrile into ketone. Give me one reagent which can convert nitrile into aldehyde.
dilute H2. Oh wait, no.
Ask me.
Mom, can you repeat the question?
I want you to convert nitrile into aldehyde.
We can use dibol H.
Very good. That's right. We used dibol H to reduce nitrile into aldehyde. Now, if you want to convert this nitrile into ketone, then use Grignard. That's it. Okay. Grignard followed by water hydrolysis, obviously. So, what is the simplest way of understanding this reaction? The carbon here becomes ketone. This R dash comes and attacks here. Nitrogen goes out as ammonia, and the remaining will be magnesium salt. Clear, ma?
Yes.
Ma'am, after forming the aldehyde,
Hmm.
when we use Grignard, we'll get an alcohol, right, ma'am?
Again, if I use a Grignard only, I'll get alcohol. I only form ketone, na. I'm using only 1 mole.
Ma'am, that will form benzaldehyde, right, ma'am, after the divalage.
Which one you're saying? I am taking RCN. I'm taking Grignard. The R
Okay,
dash
okay,
would go
ma'am.
and attack it. Huh? What happened?
I was
Ah,
looking at the first example.
okay. So this Grignard can also be used for aromatic nitriles as well. You can see benzonitrile is also getting converted into ketone, acetophenone. Okay. The next reaction is from acid chloride. This year CBSE NCERT board exam had this question. I think they wanted to convert benzoyl chloride into acetophenone. Yes, I think this was the question. Benzoyl chloride to acetophenone. So we are using the Gilman reagent here, R2CuLi. So I am taking C6H5COCl plus CH3 twice CuLi. Only one of the R group will go and attack according to Gilman, right? C6H5 COCH3 will be there, and one more R is there, right? That R will go with copper, and lithium will form the salt, lithium chloride. Okay, pa? Here